Okay, let's see one more non-exact differential equation. Yeah. Uh, Here it is not homogeneous. The function is not homogeneous, but clearly I can trace out here that it's of the form y into xy sin xy plus cos xy. Whatever functions are there, they are all functions in xy only. Okay, similarly, if I take x common, of course, into dx, x common xy sin xy minus cos xy. Clearly, it's obvious that I can apply the second integrating factor type provided it's non-exact. Okay. Yeah. This whole thing is my m and this whole thing is my n. Okay. What would be dou m by dou y, guys? Dou m by dou y would be what? UV rule I'll be applying. Okay. So 2xy sine derivative is what? Cos xy. Xy derivative with respect to y would be x into 1. Okay. Oh, shit. I should be using UV rule. I'm so sorry. I have to differentiate y squared first. Put sine xy as a constant plus xy squared as a constant. Sine xy derivative is cos xy. Xy derivative with respect to y would be x into 1. Okay. The first term. Now coming to the second term, y derivative is 1. Cos xy derivative is minus sine xy. With respect to y na, so x into y is what I'll have. Okay. Let's observe what would be dou n by dou x, guys. What would be dou n by dou x? Let's see. It looks complicated. It's not. Okay. X squared y is there na. So 2xy sin xy is as it is plus x squared y is as it is. Sine derivative is cos xy. Xy derivative is with respect to y is x into 1. Okay. Minus x derivative is 1 cos xy. Okay. Plus, not plus of course. Again, there's a minus sign for the whole term. So it is minus x into cos xy derivative. Of course, it will be plus sin xy. Xy derivative with respect to x would be 1. Of course, here it is xy derivative with respect to x would be 1 into y, guys. Okay. Almost all the terms are same. Okay. But then there's one small change here. This term, these two terms are same, but there's a plus minus variation. Okay. Coming to this term, what's this? Y derivative is 1 here. Just a second. Y derivative is 1 here. And then cos xy will be there. Yeah. This term and this term are same, but there's a change in the sign, plus and negative. So obviously, dou m by dou y not equal to dou n by dou x. The given differential equation is not exact. You will write like that. Given differential equation is not exact is what you will write. Okay. After writing it, you will proceed to find the integrating factor, and I'm pretty sure what's the integrating factor in this case? It is 1 by mx minus ny. Okay. It's difficult, a bit tedious to evaluate, but then it is fine. Okay. M you multiply with x. So I'll be having x square y square sin xy plus xy cos xy. That is my m. What is my n? Multiplying with y, x square y square sin xy minus of minus would be plus xy cos xy. Okay. Yeah. Anything that cancelled off can be cancelled. If nothing goes off, I'll keep the things like that only. 2xy cos xy is my integrating factor. When a differential equation is not exact, I'll make it exact by multiplying it with the integrating factor. Okay. So I'll be rewriting equation 1. Equation 1 into 1 by 2 xy cos xy. 2. Okay. What is 1? Let me write here. The given differential equation is my equation 1. Okay. Yeah. So what I'll be getting? Let me write it. Xy squared sin xy by 2xy cos xy plus y cos xy by 2xy cos xy into dx. This is my m plus. What's my n? X square y sin xy by 2xy cos xy minus x cos xy by 2xy cos xy. This is equal to into dy is there is equal to 0. Anything goes off, just see. Cos xy and cos xy goes off. Y and y also goes off here. Here also cos xy goes off. X and x goes off. So this term is not independent of x. Not independent of x. So I don't want this. Okay. This would be what? X goes off. Y also goes off. So I'll be having what? Y by 2 sine xy by cos xy. Of course, this can be written as tan. Anyways, it's fine. I know how to handle it. Now, this term would be what? Integral 1 by 2x dx. In this, nothing is there. Only second term is there. 1 by 2y dy. This is equal to integrating constant c. This term is like f prime of x by f of x, or this is tan x, right? Okay. So f prime of f of x would be what? Log f of x. Of course, cos derivative would be minus sign, right? So what I'll be doing, I'll be taking a minus, let's see, I'll write here, minus y by 2 is taken out. Minus sign xy is taken in. Cos xy is also taken in. I'll write this formula if in case you have it out. Integral f prime of x by f of x kind. If I make the substitution cos, it is nothing but log x. Okay. So that's what I'll be doing here. And this one is very simple. 1 by 2 into log x minus 1 by 2 into log y. Of course, I can take the integrating constant also as log c. Nothing wrong. Because anyways, the first term also would give me a log only. Minus y by 2. Okay. What I'll be getting would be log. There's a negative sign, of course, log cos xy is what I will have. I've integrated. But then xy derivative with respect to x, I'll be taking in the denominator. Y goes off. Cos xy power minus 1 is what I will have. So if all logs go off, what I'll be having is half log x by y is equal to log c. So what I'll be having, just see here. 2 I can take towards the right, that's fine. There's a negative sign. So this becomes ln secant or log secant xy, okay, plus log x by y is equal to 2 log c. Or if I remove log on all sides, I'll be having x by y secant xy. This is equal to c squared. That would be my answer. I can rearrange it in any way I like, or I can leave it as it is also. Okay, this is c squared. This is how I'll be doing for the second integrating factor. As I have made a mention in that video, either they'll be there in trigonometric functions where x and y are inseparable, or there'll be something like this. I can clearly make out x and y are together. In such a case, I'll be using the integrating factor 1 by mx minus ny, especially when the equation is not exact. If it is exact, I have no problem. Okay. Yeah. I'll do one more problem on non-exact.